about 275. It should be no surprise there, right? About midway between 6 and 7. Because if you double that, that's midway between 12,000 and 14,000. That's where 13,000 would be. It's right in the middle of this line. And we set down 275. We don't have like the lines to help us, so you play X marks the spot. Like my kids do all the time. They think they kill pirates all day, I think.
Let's go.
Seems to be all the pirates do too. So you just draw this out. And about there is what I have. So that is our M1. Okay, great. And what time was this? I'll just put time 00 because it doesn't put a time. This just represents minutes. So M1 at time 00, I got this 275 at a range of 13,000 yards. Okay, so that's point 1. Then 5 minutes later, the bearing range of the contact's 277 at 11,000 yards. All right, I always start with my range rings first. So 277, 11,000. Holy cow, is that loud or is it just my hearing aids picking that up?
No, it's loud.
I mean, yeah, and then I know I speak loud like constantly 100% of the time, so I'm sorry for the loud noise, but let's continue. 11,000. This is what I have. So that is the distance from you down 277. And try to be as exact as possible. For those who jumped out on the homework, you know the tolerance is, shall we say, unforgiving. So 277, just draw it out for E, be as precise as possible. About so. That's what I have for my M2. Write this out in pen so you can see it. So that's M2, and it says 5 minutes later, so I'm just gonna write 0, 5. 0 and 5. Great. Okay, then you go through your usual gamut of questions. We'll run through that too, just to refresh. I just got told what NGSP was this morning, so I know you have that as your resource, but I mean, I'm your instructor. I need to be helping you through this also. So forgive me if this is old hat already for the pros in the room. So something like so, that's going to be your RML right there. Does everyone have some sort of description? Okay, so that's your RML, your first one anyway. And always from this, you can get your DRM, right? The question doesn't ask for this in the practice. I don't know why, but let's just run through that. Your DRM, you go from E, follows the same direction, and it's about there. Looks like I drew a freaking dotted line. I'm not that good at it. That's just a electronic thing going on. But the DRM would be 084. It didn't ask for that, but that is how you get it. All right, but then what we really want to know, right, eventually is their course and speed, so let's do that. Let's just draw that out before we forget. So R and then M is somewhere here. So RML is going this direction, and from R, right, it's continuing the same direction. No surprises there. Great. Right, your MRM. Well, let's measure. What is our measurement of relative motion? That is our first question. Yeah, let's see. Yep, that's what I have too. 2,000 yards. Any surprises there? Everyone see the same? Okay, 2,000. Great. So this may not be a surprise to you, right? If you're going to ask for the SRM, I would put this MRM down in your nomogram. So put it down there. $2,000 yards. Great. All right, now it asks for our SRM. The SRM, alright, so what's the time difference we're talking about here? 5, right, but because you see it first, and then 5 minutes later, you see it again. Now, mind you, okay, real life, you see it the whole time, your radar is tracking it, but you take what they call hits, meaning a few minutes later, you get this information again. Yes, Russell?
How'd you get 2,000 yards again?
Well, what I did was, it's my MRM, right? So it's the relative distance between, well, the only thing relative on this board, M, the maneuvering contact. So the distance between M1 and M2. M1 and M2. I measured that out, and I got about 2,000 yards. That is your MRM, your measurement of relative motion. You're measuring the distance between the relative contacts positions. Wait, 12? Oh, SRM at 12? Yeah, let's see. So let's plot out the SRM here. So 5 minutes later, it traveled 2,000 yards. Again, this is all relative. 2,000 yards relative. So then you draw a little line here. And I got it, yes, SRM of about 12, maybe a little less, but I'll just say 12. As my SRM. This is my distance of M1 to M2, and this is my time from M1 to M2. There, and there. So I drew a line, there we go. Oh, I guess I could have actually drawn a physical line. I'll do that, why not? Like so. Anyone need me to review that so far? Okay, this is hopefully becoming a little less scary, a little more routine. Maybe even boring at this point, but we're gonna keep going. So right now, so if I'm here, and if you drew out the ship, you would see something like what my pin is doing. This is the bow, this is the stern. They are here, so they're on your starboard bow, on your front right, if I have to say it such way still. And at first board, they're 275 and 277. All right, so 275, 277, it's on my starboard bow. What kind of bearing drift is that? That's the next question. It's a right bearing drift. Okay, good. So it's increasing numerically. This is on your starboard bow. It's continuing this way, toward your right side. Okay, great. Contacts course, let's work that out. Right, so you have their SRM, that's about 12. So remember, SRM is equal to the RM line length. This is the speed triangle. RM is the relation between your course and speed R and their course and speed M. So let's measure it. It's 12 knots. So we use the speed scale from R about so, about here. That's their M. So their E to M is something like that, graphically speaking. Anyone need me to review how I got there? Really, no problem at all with these questions. Yes, Russell?
I was a little behind, I understood.
Okay, so we need to know their course and their speed. So this is our course and speed, and the distance from E to M is the same length as the SRM, right? Because E to R is our true course and speed, E to M is their true course and speed, and R to M is the relationship between the two. And remember, arrow length, line length is what? What does that mean? How long the line is in the speed triangle? Anyone? Okay, so it represents speed. The longer the line, the faster it's going. All right. So this line length is equal to the relative speed, the SRM. So the SRM, we came up with 12 knots. So I just measured that out from R, since it's the only point we have. And I got M, E to M, their course and speed to be represented by this line. Yes. But remember, the length of these lines in this big triangle is a representation of how fast or slow you're going. The longer the line, the faster you're going. RM is, I mean, it's relative. It's not coming from E, from Earth. So it has to be relative. We just measure it. The SRM is 12. Draw that there, and voila, you get M. I think I'm going to be slightly off with this problem's answers, but anyway, we'll see how well your instructor does. So E to M, well, let's first figure out speed. What is their speed? So you measure it, right? Because the length of the line represents how fast they're going. So have something like that. This is a speed, right? This isn't a real triangle on the face of the waters. So we measure that out. I have about 5 knots for their speed. So I'll just draw that somewhere. So the maneuvering contact's speed equals 5. Next is their course. Now this is where being as exact as possible pays dividends, because as you saw, the slightest change in your dots on your homework or whatever will change your answer a lot. So try to make it as precise as possible. To where you drew that intersect. And I have about maybe 157.
157.
We'll see how right or wrong I am. 158, 155, something like that. Okay. So I have their speed at 5, their course at 157. So if they're going 157, if we were to draw this out, we're here at this triangle going this direction. They would be like here, going this direction. So in terms of true, this is what it would look like, these two triangles. But now it asks for CPA bearing, CPA range, and time of CPA. So on what line is the CPA going to be on?
It's going to be on
It's perpendicular
your
line.
M.
Yeah, your RML. So so this is where they were, this is where they are. You project that out. They're going to be somewhere here. Where they're going to be closest is right somewhere around here. No surprise there. So what you do is, the way to find out where exactly it's going to be closest, you use your parallel plotter. This little line, remember, with the 270, the W beneath it is this line. That's how you get your 90-degree angle, your shortest distance. So you take it from the RML, something like that. Something like that. So that's about your CPA point. Alright, so bearing should be easy. You just measure out from E for its true bearing. I have maybe 354. Something like that. You should see something around there.
355.
355, 354, anything significantly different than that? Okay. Alright, so that's the CPA bearing. The distance, you just measure it from E. You're at E, they're going to be at CPA. Oh, let's see how far that is. What scale are we using?
2 to 1.
Alright, make sure you use that 2 to 1 scale. If you get screwed up with your scales, it's gonna get all your answers wrong. So 2 to 1. So maybe a range of, shoot, maybe 2,300 yards, something like that. You'll see the same thing.
I got like
I'm gonna write 2300 for now. We'll see, you know, who's correct. And that wasn't meant to be passive aggressive or whatever. It's just that we will see. Okay. All right, and for the time of CPA, can someone explain to me how we get that? Yes, question.
The scale at the bottom.
Yeah, the nomogram. Yeah, so what do we already have?
We have distance and speed.
We have distance and speed, okay, but we have to quantify the distance. We haven't like figured out how far it is from where they are to where they'll be at CPA. So you measure it, right? From M2 to CPA, like so. You just measure it. That's how you get your relative distance. And you use your 2-to-1 scale. Maybe 10,800, something like that. Or if you were to round it up, 11,000. I find that don't round up unless you have to. In your answers, sure, round. But in your way to get to answers, I would include even the smallest stuff, the smallest differences, because it might save you, you know, that plus or minus 2 degrees or whatever that you need to get the right answer. So I have about 10,800. Let's put that down here on the distances. So I have about a little short of that 11,000 mark. So that is my M2 to CPA distance right here. We're assuming our course and speed is going to stay the same and their course and speed is going to stay the same. That's just the assumption you make. That's generally how people drive. So you just, the SRM is going to stay the same, therefore, you just draw it out to the intersecting point. I have about 27 minutes. Everyone else see the same? 26. Alright, so again, the SRM, your course and speed, their course and speed, it's staying the same. So the relative speed, the SRM, that is also staying the same, right? Just like the two trains, if they're going the same speeds, that relative speed will not change. Alright, great. You're looking for a time, but this is basically asking where are they going to be between, you know, between now and CPA? How long is it going to be? Alright, you find out from where they are now to where they're CPAing. So you have to measure this distance. If you do, I got a little short of 11,000 yards.
Measure what distance?
I'm sorry?
Measure what distance?
So from where they are now, M2, to
Oh, to
where they will
CPA.
CPA. So, I mean, and that's what you're asking. How long is it going to be? And you're not asking, when you ask how long is it going to be, you never say that in relation to 5 hours ago. You say that in relation to now. So that's what it's asking. Right now to where they're going to be closest. So I got about 32, 33. Alright, so first let's check the answers, right? Just to double check your work. But then we're going to go into contact avoidance again. Alright, so let's see if I screwed this up. Alright, so I had an MRM of 2,000. This is 2,200. So if you got 2,200 plus or minus 200, you're okay. SRM of 13 knots, I got 12. So it's plus or minus 2 knots. Bearing drift, all right, we got it, you know, sorry, there's no tolerance here. It's either right or left, you know, so in this case it's right. The contacts course, I got 157. Ooh, I'm off by 1 from that. The answer is 154. So yes, your instructor would have gotten that wrong. And then their speed is 5.5. I put down 5. And yes, decimals are okay. You're not going to be penalized for that. For, you know, the very literal people in this room, 1 decimal, like a tenth of a knot or whatever, is more than precise enough. You don't need to go into further than that. Yes?
I'm still confused on how you get the RM line. What is that?
The RM line? Like, are you talking about the length of it, or like,
Like where you put it. I know it's on that like parallel line, but like I don't know how you get that
how you know where M is?
Yeah.
Yeah, okay. Do you mind if I run through this real quick and then I'll go through that? Okay. Contacts, let's see, CPA bearing, I got 354, but the computer answers 355. The CPA range, I got what? 2,300 yards, the computer answers 2,400 yards. And then time of CPA, I had at 27 minutes, so I barely got that. It's 25 minutes is the computer answer. Okay, so yes, I got one of those wrong, so I guess I'm like a B+ student or whatever. But okay, but the question was how you know the length of R to M? Because just with any triangle, right, where the line stops is where the corner is, right? I mean, just like here, this line goes, and then this line stops. Okay, that must be the start of that triangle's corner. So to find out where M is, you're trying to find out where this line stops. How long is it going to be? How long is this line? Do you need to quantify that? But you already did. It's 12. It's 12 knots long. So this is a representation of speed, this triangle, and the R to M is your relative speed. You are R, they are M. The relation
Okay,
between
that
the
makes a lot more sense. I was
two
just
is relative, right?
matching dots to his.
It's like you and, I don't know, a football you're pitching, or you and another student you're trying to avoid when you're getting to classes, walking from A to B. That's all this is. And the whole deal with the speed triangle, right? The direction of the lines from E, yes, that shows the true course. But the length of all these lines, that's just speed. If E to R was longer, we'd be going faster. Longer, we'd be going faster. If E to M was shorter, we'll be going slower. So this line here, how long it is just the speed of relative motion. It's the speed length. Yes, Russell?
You're using the 5 to 1 scale for that?
Yes, always use the 5 to 1 scale for any speed.
Alright, and then are you cutting it in half because it's a 2 to 1 scale?
Can you say again?
Are you cutting it in half because it's a 2 to 1 scale?
No. So the scales are completely different. So we decide, when we initially decide what scale to use, that is for distances only. Distance scales might change, but your speed scale never ever changes. It's always the 5 to 1, independent of distances. So this thing here, it's its own beast. It's like you have this radar picture, and then you decide to click this button or something like that shows the speed triangle on top of everything else. It's related to like the contacts around you and stuff, but you measure it differently. You measure it on that 5 to 1. Does that kind of make sense? Are you sure that was?
Well,
That,
I'm just, like,
if you were to say hoo-yah with that tone, it would be like, I don't know, like a depressed hoo-yah or something.
Well, no, I'm like doing it on the 5 to 1 scale and I get like, it's like a way like wider line.
You take away what?
It's like a wider line. I get like a,
It's longer?
yeah,
What SRM do you have?
12?
Can you measure it on the 5 to 1?
Yeah.
Is your E to R down 240 at about, what was it, 12?
Wait, what'd you say?
Is your E to R 240 at 12 knots?
Yeah. Yeah, yeah, it is. Oh, yeah, I think I just, wait. I can just ask someone.
Yeah, or follow up with me later, that's fine. Okay, but I guess most of you all right, this looks pretty accurate, and the answers the computer look okay, makes sense? All right, so more of the same deal, this is the third time we've done this. Now we're gonna come up with something different. All right, so you're here, they're here, and now you know they're both power-driven vessels. So what kind of situation is this, if you can see them? You hold it on your starboard side. You know, where you're going is crossing. Oh my gosh, crossing situation. Yes, all right. Now, okay, for the test, you're not gonna be asked what kind of situation this is, okay? You're just gonna be told to do blah, but I also want you to like be using your brain a little bit for this. It helps make it a little more relevant. So right now our CPA is on our starboard side, and that's at what? What did we say our CPA was? About 2,400 yards. Okay, what's happening is we're cutting in front of them. So they are here right now. Eventually at CPA they're going to be there. Don't you see how we cross their bow? So they start here. Remember, E to M was their course and speed. They're going to be here at CPA. What we just did is drive right in front of them. We don't want to do that. Let's instead pass astern of them. All right, we do that, right? If you think about it, crossing situation, you're here, they're there. You're either going to slow down and let them pass, or you're going to turn to starboard. Okay? So there'll be something like, by turning to starboard, avoid the contact by, oh, I don't know. Let's come up with something a little more drastic. Let's say 4,000 yards. Okay? So you come to starboard. If you come to starboard, on what side are they going to be?
Worse.
You're going to be on your port side. So they're going to be somewhere around here. At CPA, I should say. All right, so what do you do? I said 4,000 yards. You take your divider. Compass is also a perfectly acceptable word. Your divider, you measure out 4,000, which should be really surprised when the 2-to-1 scale is going to be at this 2 circle here. So their new CPA is going to be somewhere around there. Okay, great. So are we going inside of 4,000? No, we're not. It's 4,000 yards at least. Yes, Tordai.
Why are you changing your CPA to the other side of the?
So this is a little cerebral, I guess. But if you're turning to starboard, the question might say something like, turn to starboard to avoid the contact by 4,000 yards. Okay. So if you're turning to starboard, they're there. You're turning to starboard. Where are they going to be? On my port side. So where's that CPA going to be? On your starboard side or on your port side? Yeah, so you see that it might involve some kind of question like that. Your real question is, where are they going to be at CPA? And if you do blah, well, just keep in your mind, that means they're going to be here, or they're going to be there. That kind of thing. Just did that. Okay, so great. So what I do is I draw a new RML for where I want them to go. Not what they did, right? They already did this. You can't change the past. It's like a theme from a really dumb Hollywood movie or something like that. You know, it's like generic, but like supposed to be meaningful. But anyway, I digress. So you take it from M2 to this new CPA. Now we said no less than 4,000 yards. So don't go inside of this 4,000 yard circle. That's not what you want. You want to be skimming it. Like here to there. Something like that. That's where you want them to be relative to you. Following that line. Does that make sense? 4,000 yards off your port side because you turned starboard. All right? So what's changing here? Our course and speed or their course and speed? Our course and speed. Okay, great. So if our course and speed's changing, what's staying the same? They're doing the same thing, right? We're not forcing them to move. Yes, you're a warship, but I saw this abused in the high seas sometimes where like warships just try to like barge their way through stuff. Don't do that, okay? Just because you have a gun. You're like either, please. And then, right, so you're drawing it backwards from M. Usually we draw, right, with this original RML. You bring it down to R, draw it in the same direction. But here you reverse course from M. You're trying to find another example of R. So R is going to be somewhere along this new line.
And you said there is two ways, we can either continue our course or continue our speed.
Yeah, either change your course only or
Or
change
change
your
something.
speed only. Yes, you can do both, that's fine. But we're gonna work on just course or just speed.
And
Alright.
when we're doing an exam, would we be expected to do both at some point?
Yes, probably. Alright, so let's start with speed, okay? So your original speed was 12 knots. So your speed's gonna stay the same. Let's just change our course. So the speed's the same, we're gonna change our course. So this right here is your line of possibilities. Right there, that's your new RML. You just don't know where R is. But if you keep your speed the same, all you do is place X marks the spot. So there we go. Oh, my lighter is dying. In a second. So we said 12 knots. Let's measure that out. That's 12 there. You measure it out from E, right? Because you're making a new E to R. So if it's intersecting all these possibilities and my speed is 12 knots, then it's a line that's this long from E to R. So right there, that's a new R, potentially. I'll label this R1. So the speed's the same, but we're really trying to get at. Yes, yeah, if you keep your speed the same, there is a way to avoid them, but what am I changing? I have to change my course, right? I mean, if you're in a crossing situation like that, if you keep your speed the same, sorry, that's not gonna fix it, you gotta turn. So the course is just the direction of E to R, no surprise there. Or I should say E to R1. And it should be something like 281
How did you find your R again?
for the R point. So remember, we have this new RML showing where we want them to go. The RML line is parallel to the RM line. But because your course and speed has to change, that means your E to R has to change. So you bring it to M. Yes, it's going to be parallel. Usually you'd start from R and go the same direction, but we don't have R. You have to go back. R is somewhere up here. We don't know where. So you bring this new RML to M, draw it back in this direction from M. That is where our new R is, somewhere there. Any other questions? Am I going too fast? Kind of makes sense? Yes.
Is R1 the speed from M or is it from the center?
It's always from this, well, it's the relative speed from M, I guess. It would bring a new SRM.
So
But
what's
from the center, you measure it, I mean, you're going 12 knots, over the earth. That is your true speed.
So you just measured 12 knots from E to the new M?
Yeah, to the new line
To the new
from
line
M,
from M.
yes. So the length of this line is equal to 12. But you're not just gonna draw any good old line that's 12 knots long. It has to intersect what is possible for what you want. This line right here. Is that kind of clear? Y'all sure this makes sense? It's okay if it doesn't. I can go through it again. Okay. Now that you're perfectly great at this problem or whatever, so that's your speed. But let's say you want to be lazy and maintain course. Okay, so you're originally going E to R. Now you want to maintain course. I mean, this sort of already intersects it for you. But E to R is going 240. So it's somewhere between this line of possibilities here and 240. You just intersect it. And you might notice your original E to R already does intersect the new line of possibilities. So this, so I'm gonna put a big dot here and label it R2. So instead of turning starboard, you could just, and maintaining speed, you could just maintain your course and slow down a heck of a lot. I mean, this is not really surprising, right? When you put 2 and 2 together, again, the way to, if the contact's here, they're going this direction, you open up CPA with them either by slowing down a lot. If I'm going here and I stop, that person there is just gonna pass me. But if I wanna keep walking, I just turn to the right. Even if I'm walking at the same speed. It's just giving you the same darn thing. And if you're to draw out like new pictures of your ship based off of this new R here, this new R there, it'll illustrate that in relation to them. Does that kind of make sense? Is anything unclear about what I did there? Okay, well, since we're perfectly clear on that, let's move to stationing.
Oh wait, no, can you,
Yes, we said.
can we go over that one more time?
Sure. All right.
Wait.
One more time. We won't go over this again on Monday. Okay, I just want to dip our feet into it. All right. So this is looking pretty crowded as it is, but we originally just ran through the normal problem, right? M1 to M2. M1 was here. M2 was there. This thing here, this line that my parallel against, was my original RML, my original projection of where they should be. Using that, I got, it was a CPA right there on my starboard beam. But look, this is what they're doing. So if you draw out like E to M, in terms of where they're going, they would look something like this or this. I would look like this. Why am I cutting across their bow in a crossing situation? No bueno. So I come up with a new solution. Where we really want them to be is off our port side somewhere. So by turning to starboard. So the question in your homework, partly your homework, partly your practical, will be something like, you turn to starboard. If you turn to starboard, how do you solve this? So what you do is, if you turn to starboard and they're here, where are they going to be? If you turn right,
To your port.
they're going to be on your port side. Okay, so we know we want the new RML to be somewhere here, somewhere on our port side. Don't know where. And then I just gave an arbitrary number to CPA them at 4,000 yards. So you just measure that out. Here we just use your divider, measure out 4, that should intersect with the 2 on the original scale, like that. Just draw it out. Okay, so you have something looks like an arc over here at 4,000 yards. This is where they are now. You need to change where they're going to be relative to you. So what you're doing is you start with your answer. I mean, that's what's already given to you, right? Your answer is a CPA of 4,000 yards on your port side. So you draw out that, like so, from where they are now to where you want their new CPA to be. Right there. Okay, great. We drew out what we want them, where we want them to be. But that doesn't tell us what we need to do to make that happen. We need to change our R. That E to R line has to change somehow. So E to M staying the same. They're not doing anything, right? They're to stand on. E to R, you're just, it's an RML all the same. So you take the RML, you bring it to M. And originally we would start from the M, from the R and go to M. But because we're trying to find the reverse, we go the opposite direction. M, and then somewhere along here is R. If we already knew R for some weird reason, yes, we'd start from R and go in the same direction as the new RML, but we don't have that. We're going backwards from M. Somewhere along here are all the possible courses and speeds that you can go to give you this, to give you what you want. And I mean, it has to be parallel to the RML, right? We forced the new RML onto the board. That's what we want, this guy here. So really what we need to answer ourselves is, well, what do we want? Which of these courses and speeds? And the first was, well, let's just change one or change the other. So let's just change course. Meaning, if you just change course, your speed has to be the same. So you take your E to R, which was, I think, 12 knots. You just draw it up here, where it intersects the possibilities and your continuing speed, the same speed. So you maintain speed. That means your course has to change according to this line, the E to R line. And I got something like 281. Or you maintain the same course and change your speed instead. So for that, right, your course was 240, so you just intersect 240 with all these possibilities, the line of possibilities. The name is not officially the line of possibilities. I'm just calling it that to make it obvious as to what it means. Really, it's gonna be, you know, your R1 to M line or whatever. That's what it's eventually going to be. So here you see where it intersects between 240 and this new line of possibilities is down there. It's a smaller distance, right? Which means here you have a slower speed. So yes, you'll maintain the same course, but you go at a slower speed. That kind of makes sense. I see the brain friedness setting in, but at least this is starting to make a little sense. Okay, all right. We will go through this again and again and again. I do promise. All right, so we have that. Any questions about or any confusions about the process of contact avoidance and how we do that? So really, the new difference there is a new RML. And from that, a new E to R. That's what you're going for. Okay. Next, gonna go into stationing. Stationing is actually, although I know your brains probably struggle to take in much right now, you know, if I told you a random thing like, you know, Constantinople was renamed in 1923 or something, you probably not remember that, all right? But we're gonna do this anyway, because you have to be with your friend Lieutenant Joubert for the next hour. Not 50 minutes actually, hold on to hope, so it's actually less than that. We're not going to stationing, okay.